Hello, good morning, dear students. It's me, Vivek, sir. Today we are going to study class 10th chemistry double displacement reaction, oxidation reduction reaction, and the last part of this chapter is rancidity and corrosion. In earlier video, children, I had explained the type of reaction that was combination reaction, decomposition reaction, displacement reaction, and in this we are going to study the remaining part of this chapter. Let's start. Double displacement reaction. Children, I've already told you that displacement means removal of atom, means how the highly reactive metal displaces the less reactive metals. Clear? So there will be double displacement. There will be two atoms will exchange their position according to their reactivity series. So those reactions in which two compounds, clear children, two compounds exchange their ions. There should be exchange their ions between two compounds and form product is called double displacement reaction. Clear children? For example, suppose this is a compound AB and this is the compound CD. It is the combination of metal and non-metal. It will also the combination of metal and non-metal. So A, being a highly reactive metals, displace the less reactive metal of C, so and form the product AD, A plus. Clear children? So, we can take the example silver nitrate, sodium chloride. If we write these compounds into their ionic form, so Ag plus NO3 minus Na plus Cl minus. Sodium being more reactive than silver, so it displaces and form the product because positive charge always attract negative charge. So it forms sodium nitrate and remaining is silver chloride. Second example, potassium sulfate. If we write also into their ionic form, K plus SO4 2 minus, Ba2 plus NO3 minus. So barium attract negative charge. Being a positive charge, it attract negative charge. Plus 2 and minus 2 will cancel. It forms barium sulfate and potassium nitrate. Clear children? Now, double displacement reaction is divided into two parts according to the formation of product. If it produces precipitate and insoluble product, that will be precipitation reaction, and if acid and base form salt and water, that will be neutralization reaction. Let's see children. Neutralization reaction. When an acid, underline this point and note in your copy. When an acid and base react to form salt and water, the product should be only salt and water. Whatever be the salt children, but it should be salt. If it forms salt and water, it's called neutralization reaction. Clear? We can write also this acid plus base, salt and water. So the whole reaction will be neutralization reaction. For example, hydrochloric acid and sodium hydroxide. This is acid and this is base. We will read in detail this type of acid and base in next chapter. So write into their ionic form H plus Cl minus, Na plus OH minus. So there will be formation of sodium chloride because positive charge attract negative charge. It forms sodium chloride plus water. Hydrogen sulfate, write into their ionic form, it forms H plus SO4 2 minus, K plus OH minus. So there is a radical SO4 sulfate. So being a positive charge potassium, it attracts. So there will be K2SO4 plus S2O. So we can see when acid and base react, if they produce salt plus water, that will be neutralization reaction. Clear children? Now second is precipitation reaction. Children, I have already explained that what is precipitate. Again, I would like to remind you, an insoluble solid product which produce during a chemical reaction. Clear? That is precipitate. So those reactions in which aqueous solution of two compound on mixing react to form insoluble compound, children, that is insoluble compound which separate out as a solid is called precipitation reaction. Clear? When an insoluble solid compound is produced, when two aqueous solution combined, that will be precipitation reaction. For example, HCl, H plus, Cl minus, right into their ionic form, Ag plus, NO3 minus. So positive charge I have told you, AgCl plus, and this is aqueous solution. Children, the word aqueous means those solution which made in water. When HCl made in dissolved in water, that will be aqueous solution. When silver nitrate dissolved in water, that will be aqueous solution. So when they will combine, if they produce solids insoluble product is formed along with solution, that will be precipitation reaction. When precipitate is formed, and the symbol of precipitate is this, downward directions, this so that precipitate is formed. Clear, children? Now our next topic is oxidation reduction reactions. Children, oxidation reduction reaction, first of all we have to read those reactions in which oxidation and reduction takes place, that will be redox reaction. Clear, children? So first of all we have to know what are the conditions for oxidation. There are two conditions: addition of oxygen or removal of hydrogen. Clear, children? And those substances which add oxygen or removes hydrogen, that will be oxidized substance, and those substances which gets reduced, that will be reducing agent. We can understand with the help of example. For example, suppose this is copper oxide, children, okay, and this is hydrogen. When they will combine, they produce copper plus water. So here copper oxide get converted into the copper, and hydrogen, see children, hydrogen, there is hydrogen, when it will combine, it adds oxygen and form water. So oxidation has taken place, and hydrogen will be oxidized substance, because I have told you that those substance which adds oxygen, that will be oxidized substance. Clear? See, reduction. For the formation of reduction, there are two conditions: addition of hydrogen or removal of oxygen, just opposite of oxidation. And the substance which adds oxygen, which add hydrogen or removes oxygen, is called reduced substance, and the substance which gets reduced, that is called oxidizing. Just keep in your mind, we can understand with the help of example. See, again, copper oxide get reduced to copper because there is a removal of oxygen. So copper oxide is a reduced substance, and the substance which get reduced, that is called oxidizing agent, and this is also called oxidizing agent. There is hydrogen. When it combines with oxygen, it forms water. So there is addition of oxygen, so oxidation has taken place, and the substance which gets oxidized, that will be reducing agent. Clear, children? Let's take another example. Zinc oxide plus carbon. See, there is a zinc oxide and there is zinc. So zinc oxide reduced to zinc, so reduction has taken place. Carbon gets oxidized and form carbon monoxide. So this is a reduced substance, there is oxidized substance. And I've already told you that those substances which get reduced, that will be oxidizing agent, and the substance which gets oxidized, that will be reducing agent. Clear, children? Let's take another example. Hydrogen sulfide plus chlorine gas, it forms sulfur plus hydrogen chloride. Just try to understand, children. There is a hydrogen sulfide and it gets converted to sulfur. So there is a removal of hydrogen. I've already told you, if there is an addition of oxygen or removal of hydrogen, there will be oxidation. And in chlorine, this chlorine gets converted into the hydrogen chloride. Means there is addition of hydrogen, gaining of hydrogen, we can say. So reduction has taken place. Hydrogen sulfide oxidized to sulfur. Clear, children? And chlorine is reduced to hydrogen chloride. Clear? Chlorine is the which get the substance which gets reduced, that will be oxidizing agent, and which gets oxidized, that will be reducing agent. Let's try to solve these questions. Name the reducing agent in the following reaction. We have to find out the reducing agent, children. Manganese dioxide plus aluminium, it forms manganese plus aluminium oxide. Here aluminium, when it combines with oxygen, it forms Al2O3, and when there is a removal of hydrogen, so reduction is there. Yes or not, children? Manganese dioxide and manganese, there is a removal of oxygen, so removal of oxygen means reduction has taken place, and there is aluminium oxidized from Al2O3. So those substances which gets oxidized, that will be reducing agent. So aluminium is reducing agent. Clear, children? Now the last topic of this chapter is effect of oxidation in our daily life. What are the effect of oxidation? What are the harmful effects which we see in our everyday life? See, children, if there is a harmful effect of oxidation on metal, that is called corrosion. And if there is a harmful effect of oxidation on food, that will be rancidity. Clear, children? Let us see how did oxidation play important role. What are the harmful effect in our life? Because without oxidation, no any substance will burn. Clear, children? So oxidation is also important for our combustion. Let's see first corrosion. It is the slow process, children. What? It is the slow process. Corrosion is the slow process. It is not fast process, children. In which metals are eaten up. The word eaten up means it is the surface of the metal starts disappearing. Slowly eaten up. Gradually means slowly. Gradually by the action of moisture, means water, acid, carbon dioxide, etc. We all know it very well that many of the acid, base, moisture are present in the atmosphere. When these moisture, acid, carbon dioxide, etc. are we can say that when it affect on any metal, then the surface of the metal starts disappearing and the corrosion has taken place. Let us take an example. Fe. This is iron and this is water. There is X is the number of molecules of water. Clear, children? Because how many molecules of water will attach, how many number of moisture will attach on the iron, it is not certain. So when it attacks on iron, it forms Fe2O3 XH2O. This is the rusted of iron. So the process in which metals are eaten up gradually or slowly by the action of what? Underline this point. Clear, children? This is called corrosion. So these are the harmful effect of oxidation. And now we will read what are the prevention from this. First, by applying paint on metals. By applying paint on metals. Let's see, children. Suppose this is a metal. Suppose this is metal. When it is painted by any other layer, and we have known that the electroplating is also done by the with the help of electric current. So when it is painted, then moisture acid will attack on this. So if there is zinc, silver, so it combines with the oxygen and form the compound silver oxide or zinc oxide. So being a less reactive, the oxygen will not enter into inside of this metal. So our metal will be safe. Clear, children? So by applying paint on metal, the water, the moisture will not come in contact with the metal. That is why we can prevent from this. Easy, children? Second, by galvanization. Children, in previous class, in 8th, 9th, we have studied also when zinc layer is put on some iron articles to prevent from corrosion, that is known as galvanization. Why zinc layer is there, children? Zinc plus oxygen, it forms zinc oxide. So zinc oxide is less reactive. Clear, children? It forms zinc. There is a formation of layer zinc oxide. So when moisture, acid, everything will come content in zinc oxide, being less reactive metal, it will not react with these and our metal will be safe. Clear, children? So from this we can prevent our metal from corrosion. Is that clear, children? Easy? Now next topic is rancidity. The harmful effect of oxidation on food, that is called rancidity. See, children, when food get oxidized, means when food material get oxidized, means when the food will combine with oxygen. Keep in mind, when food combine with oxygen and get oxidized, if it gives unpleasant smell and bad taste, smelling will be very bad, then this is known as rancidity. This is the condition for rancidity, because when food until unless the food get oxidized, it will not produce unpleasant and bad taste. So first of all, we have to prevent this from oxygen. That is why our food material that do not kept in any metal that are more reactive. Clear, children? So this is the condition for rancidity. So let's see how can we prevent our food material from rancidity. These topics are very, very important, children. This is the condition I am in before. We have read that how can we prevent the corrosion. Now let us see how can we prevent our food material from rancidity. Children, you have seen that why potato chips, kurkure, that are flushed with nitrogen gas. Do you think why? Why they are packed with nitrogen gas until unless other gas? So in this video we are going to discuss about all these things. Clear? Let us see the preventions. Adding antioxidant to food. First of all, we have to know what are the antioxidants. Children, antioxidants are the chemical substance. What are these? These are the chemical substance which reduces oxygen. They reduces the amount of oxygen present in the food. So adding antioxidant to food, because when antioxidant are mixed with food, they reduces the amount of oxygen and prevent from rancidity. Clear, children? So this is the very important. Some of the antioxidants are butylated hydroxyanisole. Clear, children? Butylated hydroxyanisole BHA. Clear? These are the antioxidants which are present in the market. Butylated hydroxyanisole. They are the antioxidant which we can prevent from the rancidity. Second, storing food in airtight container to slow the process of rancidification. We have to keep our food material in airtight container because we have to prevent from the amount of oxygen. If there is no amount of oxygen, our food material is safe. So storing food in airtight container to slow the process of rancidity. That is why some of the food materials are packed in airtight container. We can also keep our food material in refrigerator, because there is a less amount of oxygen are there. That is why there will be safe. Now third is replacing oxygen in the containers with another gas. Clear, children? Replacing oxygen in the container with another gas. The question can be asked from this, children. Most of the question can be asked from this. Why potato chips are flushed with nitrogen gas? See, children. Suppose this is a packet of chips, and when it flushed with nitrogen gas, nitrogen being a less reactive, so when it combines with oxygen, it forms many of the product N2O, NO2, and 2O5. So these compounds are very less reactive. That is why there is the amount of oxygen is very less in that packet. That is why our food material will be safe. So these are the prevention. How can we prevent the food material from rancidity? Clear, children? So note this point: adding antioxidant to food, storing food in airtight container to slow the process of rancidification, replacing oxygen container with another gas. Now let us see, children, the last is balancing of chemical reaction. Only we are going to revise this again because there are some doubt many students. Let's see calcium oxide. Children, how can we produce? First of all, we have to know how can we make the product, because I've already told you the number of atoms should be equal on right hand side and left hand side. Clear, children? So calcium, oxygen, and I've already told you we have to balancing of those atoms first which are maximum in numbers. 2, 1, 3 oxygen and 1, 1, 2 oxygen. So we have to balance the oxygen first. 2 oxygen, 2 oxygen, 2 calcium, 2 calcium. Clear, children? Our oxygen and calcium both are balanced. How can we make the product? See, calcium, oxygen, atomic number 20, atomic number 8, electronic configuration 2, 8, 8, 2, 2 and 6. So to become inert gas, it loses 2 electrons. Calcium 2 plus, oxygen 2 minus. Clear, children? We can make the product all these things. Phosphorus plus oxygen, phosphorus pentoxide, there is 5 oxygen, there is 2 oxygen, children. So 5 2 ja, how can we balance the oxygen? So multiply by 2 here. 5 2 ja 10, and there will be 5. 2 5 ja 10. Clear, children? Oxygen in balance. Now phosphorus 2 2 ja 4. There will be 4 phosphorus. See, sodium plus chlorine, 2 chlorine, there will be 2 chlorine, 2 sodium, there will be 2 sodium. Balance it, children. Now let's see, 2 1 3 oxygen and 2 potassium. So we'll balance oxygen first. 2 oxygen, 2 oxygen, 2 to the 4 potassium. Balance children, you can practice from the book now.